Hello, Calculus AB. I'm going to take you through some of these examples to help review for you. So on complex fractions, that occurs when you have fractions within a larger fraction. So you can kind of think of it as this 5 over x plus 1 is the bigger denominator, and then the x plus 1 is the smaller denominator. So the goal here is to simplify so that you don't have any of those smaller denominators anymore. What you want to look for is you're going to multiply both the big numerator and the big denominator by an expression or number so that all the small denominators cancel. So in this case, the small denominators are both x plus 1. So I'm going to multiply the top and the bottom by x plus 1. Okay, so parentheses are always recommended, and I'm going to do that on the top here as well. But you're going to take that x plus 1 and you're going to distribute. So when I distribute to -7, that's how we get this -7x plus 1 expression. Okay, but then notice that when I distribute to this other smaller fraction, that x plus 1 is going to cancel with this one. So you get 6 times x plus 1 on the top and x plus 1 on the bottom. Those cancel, and then you end up with just -6. Okay, on the bottom, same thing happens here. So you multiply 5 times x plus 1. Well, that will cancel out with this x plus 1, and you end up with just the 5. So notice that there's no more fractions within the fractions. So this is the simplified version, and then you're just going to simplify further after that. So distribute the -7, so you get -7x, and then -7 minus the 6 is -13. So that's where this comes from. Okay, going through a different kind here, if you have an x and an x minus 4, so we have two different small denominators to cancel. That means you're going to have to multiply by 2, here a monomial and a binomial, but you have to multiply by 2 things. Okay, and we're actually going to go through number 4 together, just like that. Okay, because that one has something else we need to talk about. Okay, so again, here we're going to multiply by something that'll cancel out all the small denominators. And so I need to combine both x and x plus 1. Both of those have to be multiplied in order to cancel both of the small denominators. So what I'm going to do is I'm going to take this whole entire expression and multiply it into the first guy. So what happens here, and I can write it out if it's helpful, but you basically get x times x times x plus 1, all of that over x plus 1. That's what this is. Okay, well, in that case, these are going to cancel. Okay, if you do it again to this one here, you're going to have minus. So now we're going to have x times x plus 1 all over x. And then these x's are going to cancel. So that's the theory. So what we end up with on the top here is x squared, right? X times x. And then here's where people mess up. You have a minus. You need to minus x plus 1, which means you need parentheses. You need to be very liberal with your parentheses. So you're going to subtract x plus 1 because that's what's left on the second fraction. Okay, on the bottom, maybe I'll do it in a different color. So you have to multiply top and bottom by the same thing in order to keep the original expression equivalent. So we're going to take x times x plus 1, and you're going to multiply in here. So x plus 1s are going to cancel in this case, and I again will get x squared. And then here again, the x's are going to cancel. And then I'm going to keep the parentheses, even though it doesn't really matter for a plus, but x plus 1. Okay, so then my final answer, I'm going to simplify x squared and then minus x minus 1, all of that over x squared plus x plus 1. as a final step here, you should see if these factor and you could further cancel, but neither one of those factor. So this will be your final answer. Okay, next page. So most of these should be fairly straightforward. The one that maybe you forgot is third root is actually it's the same as raising it to the 1/3 power. So roots and fractional powers go together. So then we get to one like this guy. So if we do the 10th root of 25 raised to the 5th power, so you'll see here that means 25 to the 1/10, and then all of that to the 5th power. When you are doing power to a power, you multiply the powers, so you end up with 25 to the 5/10 power, which obviously reduces to 1/2, which is square root of 5, which is 5. But the main thing is the roots turn into fractional exponents. So I'm just going to go through F with you. This one's kind of the hardest one, I think, on the page. So first of all, we have these fractional powers. Now, I would get rid of this 3/2 to start with. So basically, you're going to raise both bases to the 3/2 power. So you can rewrite this as 4 to the 3/2, and then times a, and then this is going to be 5/3 times 3/2. So you apply that 3/2 to both bases. Okay, well, I'm going to convert this into a more familiar form. So the 2 on the bottom means it's square root of 4. And then the 3 on the top means I raise it to the 3rd power. On the second base, you're going to multiply the fractions. So you do have to be really fluent with fractions. So 15 over 6. Okay, so square root of 4 is 2. 2 to the 3rd power is 8. So you end up with 8 there. And then you can reduce this fraction, divide them by 3s, and you get a to the 5/2. Okay, now you could also rewrite this. This is perfectly fine answer, but you could rewrite it as square root of 8 to the 5th power. But we generally just leave it like this. Okay, next page. So going through composition of functions. So I'm just going to talk you through this example and rewrite it over here as I talk through it. So composition is when you do f of g of x. Sometimes you see it as fog of x or goth, but this is also an acceptable form. So f of g of x, basically whatever g of x is, you're going to plug into f of x. So since g of x is x plus 4 or x minus 4, you're going to do f of x minus 4. Okay, after that, this is the hard part. So you have to take this entire expression and replace x with that expression in f of x. So what I like to do is rewrite f of x with parentheses wherever there is the x. So here I'm going to rewrite, there's 2. Okay, I've come across an x, so I'm going to put parentheses squared plus 1. So this is 2x squared plus 1, which is exactly what's here. I'm just putting parentheses wherever there's an x. Okay, and then I'm going to replace with the x minus 4, which was here. Okay, after that, an algebra mistake that people make a lot is they simply say that this is x squared minus 16, and it is not. So off to the side here, I'm just going to calculate this for you. But you have to remember that x minus 4 squared is x minus 4 times x minus 4. And this is a huge, huge problem for a lot of people. You have to remember there is a middle term when you are squaring a binomial. So when you FOIL this, you get x squared minus 4x plus 16, right? You do first outside, inside, last. So I get x squared minus 8x plus 16. So you have to be very, very careful when you are squaring a binomial that you get that middle term, and that's what that is. Okay, next place people make mistakes is they don't keep the parentheses because you do have to multiply everything by 2. So make sure you keep the parentheses, x squared minus 8x plus the 16, and then plus 1. Okay, and then you obviously distribute the 2. So you get 2x squared, and then minus 16x. And then you get 32 plus the 1, which is where that 33 comes from. So there is your f of g of x for this. Next one I'm going to go through with you is this number 11. Okay, this is an insanely important concept to be able to do for calculus. Okay, it's one of the major concepts using this particular expression. Okay, so I'm going to do this down here because that's where you have room. All right, so f of x plus h minus f of x over h. Now, my original expressions here are up a page, but you can see them just fine. But I have f of x is 2x plus 1. And that's all I need for this one. All right, so I'm going to use a similar process here. So instead of having f of x, I want to plug in x plus h in for x. So I'm going to rewrite f of x with my parentheses. So 2x plus 1. Okay, and I'm just going to leave it like that for a second. Then I'm going to subtract f of x. Now here's another major problem. When you subtract f of x, you need to have parentheses. People make that mistake all the time. You need to have parentheses because you're subtracting the whole function. So the whole function is 2x plus 1. So this is f of x. And then f of x plus 1, or f of x plus h, you're going to take this, I'll do it in a different color, this x plus h and replace it here. So this would be f of x plus h. So this is the numerator, f of x plus h minus f of x. Here's f of x plus h. And then minus, here's f of x. Okay, in the end, you do all of that over h. Now, the goal with this particular expression when we do it in calculus is to get that h to cancel. So if your h doesn't cancel in the end, you've done something wrong. Okay, so we're going to distribute, so 2x plus 2h plus 1. We're going to distribute the negative, minus 2x minus 1, all of that over h. So canceling, 2x's go away, the 1's go away. So I end up with 2h over h. That h cancels, which is the goal. And then you get 2 as your final answer. Okay, you'll do 2 more of those right there. Okay, last thing here, intercepts should be fairly straightforward. X-intercepts, you just plug in y equals 0. Most of the time you're going to be factoring like this. And then you're going to have your intercepts. Y-intercept is when you just plug in x equals 0. That's always the easier version. So just giving you a couple of hints on one of the hard ones here, 21. So for your x-intercepts, you are going to plug in y equals 0. So 0 is equal to x, and then square root of 16 minus x squared. Well, you're going to treat this kind of like a factoring problem. So you need to have one of these expressions be 0 so that they multiply to be 0. So either x is 0 or square root of 16 minus x squared is 0. Those are your two options. This is 0, that's easy enough. Here you just want to think, well, how do I make this 0? Well, I would have to have x squared equal to 16. So x is equal to plus or minus 4. So my intercepts for the x would be at 0, 0, 4, 0, and negative 4, 0. Okay, that's it for now.